Hello everyone, this is Unit 11, Lesson 5. This is the last lesson for Unit 11, and what we're going to discuss today is the effects of dimension area and volume changes and unit conversions. Okay, so there's quite a bit that's going on here, but it's all fairly simple, so let's take a look at it and see what we got. Once again, as I've told you in some of the previous videos, if what you need to do is if you think that you might possibly have any kind of question, you need to get some paper and keep it handy with something to write with so that you can write down your question, bring it to class tomorrow, and we'll be more than glad to cover it before we start the lesson or start the work on it. Okay, so let's take a look. Definitions and such. Any volume calculation involves multiplication of three dimensions. This means that you've got to multiply by the height, the width, and the depth. Okay, so if a new 3D object is produced by adjusting the scale factors, any one of these, scale factor 1, scale factor 2, and scale factor 3, of those three dimensions, then the scale factor by which the volume changes is the product of those dimension scale factors. In other words, the way that the volume is going to change is going to be determined by the product or the multiplication together of those three scale factor changes. Okay? Occasionally you will have something that are similar objects. So if all three dimensions change by the same scale factor, then what you have is the scale factor to the third power. Okay, so this means that if you triple all three of these dimensions, that it will change volume by a factor of 27. Alright, example 1. These two polygons are similar and they form the bases of two prisms. Okay, if the volume of the smaller prism is 26 cubic meters, what is the volume of the larger one if the heights are the same? So in this case we have two of the three that changed. So let's see what we got. So the scale factor is 7 to 4. So this means that what we're going to do is we're going to square the 7 to 4 because the polygons are similar, and we're going to multiply that by 1 and that by 26. Okay, so this gives us a difference of 79.625 cubic meters. Okay, so that's the new volume. The original volume was 26 cubic meters. The resulting volume is 79.625 or 5/8 meters cubed. Alright, example 2. If the height of this rectangular solid remains the same while its length increases by a factor of 2, along with its width decreasing by a factor of 3, what is the scale factor by which the volume changes? Okay, so if one is changing by 2, we're going to multiply by 2, and if one is decreasing by 3, that means the second one is going to be 1/3. Okay? The third one stayed the same, so this is what we have, is we have 1 times 2 times 1/3. Okay, that gives us a result of 2/3. So the resulting scale factor will be 2/3 of the original volume. Okay, example 3. The volume of a right triangular prism, in other words, the lateral faces are all perpendicular to the base, is 1100 cubic inches. What would be the new volume if the two dimensions of the base were changed by a factor of 6 while the height was half as high? Okay, so once again we find our scale factor. So scale factor 1 is going to be 6, scale factor 2 is going to be 6, and scale factor 3 is 1/2. Okay? So we multiply these together, that gives us 18. So this means we take the 1100 cubic inches that we were given to begin with, and we're going to multiply that by the scale factor of the change, which is 18. So this means that our new volume is going to be 19,800 cubic inches. Okay, some more definitions of things. This is how you convert between units, okay, or do conversions. So use unit multipliers to change cubic dimensions. If, for example, we know that 1 inch is equal to 2.54 centimeters, then in order to convert cubic centimeters to cubic inches, it is no longer appropriate to just multiply by 1 inch to 2.54 centimeters as we formerly did when converting linear dimensions. Okay, so what this means is if we're converting cubic dimensions, which is what we're talking about when we're talking about volume, it is appropriate to multiply the cube of 1 inch per 2.54 centimeters, which is going to give you this expression here, 1 to the third power times cubic inches over 2.54 to the third power cubic centimeters. Okay, so here's what we got here. This time they want us to convert 136 cubic feet to cubic miles. Okay, every mile has 5,280 feet in it. So since we're talking about the cubes of these, we're going to have to cube these scale factors. So 1 mile to 5,280 feet is equal to the 1 cubic foot that we started out, or cubic foot to cubic miles that we started out with before. Okay, so what we're going to do at this point is we're going to cube all this. So we got 136 cubic feet to 1 unit. This is what we were given at the beginning up here. We want to convert it to miles, from feet to miles. So this is going to be 1 mile per 5,280 feet cubed. So this gives us 136 cubic feet over 1 times 1 cubic mile over 5,280 to the third power feet cubed. Okay, the next thing we're going to do is cross out the dimensions that are going to cancel. So the feet cubed cancel out. So this leaves us with 136 over 1 times 1 mile cubed is over 5,280 to the third power. So this gives us 136 cubic miles to 5,280 cubic feet per mile. It gives us approximately 9.24 times 10 to the negative 10 cubic miles. Okay. Example 5. This time they want us to convert 55.6 cubic inches to cubic centimeters. So we have 2.54 centimeters per 1 inch is equal to 1. Okay, so this is what we end up with this. We take the 55.6 cubic inches to 1 is equal to 2.54 centimeters over 1 inch cubed. This results in 55.6 cubic inches is multiplied by 2.54 to the third power times the centimeters cubed over 1 cubic inch. Okay. Once again, we're going to get rid of the units that cancel. So in this case, the cubic inches cancel out. So this gives us, this is the result, 55.6 times 2.54 cubed centimeters cubed, which results in from the calculator of approximately 911.12 cubic centimeters. Okay, this pretty much finishes up Unit 11, Lesson 5. So make sure if you have any questions, you bring them to class. If there's anything else that you want to discuss about it, be more than glad to do so before we start. Thank you very much. Goodbye. Okay, and looking through the video, apparently I covered up with the end screen thing, the answer to this, so just wanted to make sure I gave you a few more seconds to see what it was. Okay, thank you very much. See you tomorrow.